Welcome back to VTU e-Shikshana program on computer aided engineering drawing. So far we have worked out problems on rectangle, square, triangle having one edge on HP or one corner on HP, and also the surface inclined at some degree to HP and some degree to VP. And also we have dealt with problems on apparent angle. So when a line is inclined at some degree to HP and some degree to VP, definitely it assumes inclination to the XY line, different values. So alpha and beta, that also we have worked out. Now let me take out one problem on pentagon. Normally in majority of the cases you get pentagon problem as the prime item in the question paper or test or in the classwork. Now let me take a pentagon. Here we have the corners named A, B, C, D, E, and I can have the references like this. The edge on HP, lamina inclined at some degree to HP. Okay, and the edge on HP is inclined at some degree to VP towards XY line or away from XY line. If the situation demands, then only you do this. Otherwise, you always better take this. So first position, second position, third position. So this is how you get the problem solved. This is change of position method as usual. Now I have a problem. The side of the lamina is 30 mm and it has edge on HP inclined at 30 degree to VP. The edge on HP is inclined 30 degree to VP. See, the edge on HP is inclined 30 degree to VP. The lamina is inclined at 50 degree to HP. Not necessarily that always you should get combination of 45-30 or 30-45. You may get any value. If you get total value 90 degree, then only you must think of. But if it is for only surface total inclination is 90 degree, then you get alpha or beta equal to 90 degree. If the surface inclined at 50 and the edge on HP inclined some value, say 40 or 50, then you need not worry. Different items. Now surface itself is having inclination more than 90, it's a problem. It's a vague problem. Now let me start working this problem. So we have already the XY line fixed and the HVVP, the standard format. Now let me have the edge condition. So from where you have to start? The lamina inclined to HP. So definitely you must make it parallel to HP. So you get two shape on HP. So this is very important. Start from top view, okay, because the lamina inclined to HP, so that is edge condition with respect to HP. So see, this is how you do it on a particular line, perpendicular line. You must have this AB, then do it. How to do manually? You have to mark 30 mm, little away from it, so that you should accommodate the entire figure. Then 108 degrees, 108 degrees. Take carefully. Normally we commit mistake by taking 112 or 72, instead of 72 we take 68. Then take same distance, mark. Okay. Then with these 2 points as center, draw 2 more arcs, same distance. So 30 mm is the side. Should take this and then draw. Then join this. So this is nothing but the top view. This is A, B, C, D. Please observe, I have started from left extreme nearest corner, not this or this. Always visible points first. Left extreme nearest corner, I am here. So left extreme nearest corner is this A, B, C, D. Then dark this portion. Now project these points, corners particularly, towards XY line. Now let me have XY line reference. should see that B and D in this particular case, B and D must coincide with a single line, and this is the point representing B and D. And next comes C. Project these points and name these points as A dash, E dash, then this is C dash, this one is B dash, D dash. Fine. We got the front view, dark. So this is what the first figure, front view, top view, when the lamina is on HP. When the lamina is on HP, this is the case. See, this is A, B, C is visible, E and D are not visible if you look from this direction. Front view is a line on XY line itself because it is on HP. Then top view is true shade. Next, give inclination to HP. So how you do it? This is done manually by drawing a line 50 degree and take this front view length and draw an arc. In computer, move and rotate, that's all, it's easy. Here you have to mark a point, namely A dash, E dash, convenient distance, and then take this distance called radius, draw. Please note that this is not midpoint, this is biased towards right corner. Okay. Now this is B dash, D dash, then C dash. In computer, what you do is, while drawing this full length, you mark this length and then one more length. That means the two entities are there. But once you move and rotate, then that gives a single one. Then you will be identifying this point. Otherwise, you have to note one particular mark with straight line concept and then do it. That also I will explain that once I will start working on computer. Now, dark this portion. Okay. Now, angle of inclination with respect to HP, lamina is 50 degree. It's very clear. It's given. This is over. Now, how to get the apparent shape? Project from present top front view and previous top view. So, you try to utilize alignment indicator in case of computer software. Here also you can optimize, draw two stoppers, I can say. Project it, left extreme, right extreme projection from this corner, lowermost projection. Then draw B and D, then this line, in this line. You know very well that A and E stops here, and this is D, this is B, and one more point C is here. Okay, since you know C stops here, you can keep here only, you do not worry about the extra. Now join these points, name it first. A, to avoid any confusion, A, B, C, D, E. Join them carefully. Yes, you got apparent shape, second figure, top view. Right now, this particular line EA or AE, I can say, is the edge on HP, or side is the side on HP. Is the side on HP. Okay, see, AE, named it. AE first position, second position. AE is the side on HP. Okay. Now that is perpendicular to VP right now. I want that 30 degree to VP. So we have done this job in case of rectangle, triangle, square, etc. Here also same procedure. First position, this assume that is top view, first position, second position, third position, or third position. This is better because if you do like this, you have to judge before you draw where to draw. Here it is easy. You draw like this, first position, second position, third position. If you draw like this space, sufficient space is there, you can try it. Suppose if you keep it like this, it may cross this. So better, unless the situation demands, don't do that. By default, you take AE. AE as the reference. I will draw 30 degree line. 30 degree line. Keep EA first. Take sufficient length E Then measure this distance, mark here, this is A. Then very easy to draw manually. Then let me assume this is M for construction purpose, M. Then draw perpendicular that houses one more point C here. Then take this distance and this, that's all. This you got, see, this you measure clearly here, and then draw parallel to this. Then take AB equal to ED, AB equal to ED, that's all. Join them. Before that, let me name, yes, join these points. Yes, I got second figure top view redrawn with AE on 30 degree line. AE is on 30 degree line. That means it is true length on true inclination. That is phi. True length on TL on TI. True length on true inclination. No question of beta because it is on HP. Now project these points onto the final front view. How to get the final front view? This is EA on XY line only because AE on ground, A dash, E dash. Topmost point is C. Draw this, project it. You know how to work in computer. Alignment indicator is there, very easy. Then in between we have BD here, project it. Then project this one. Sometimes these two lines may be very close. That will take care by the computer. Here also you can easily do it. In case of computer, you try to zoom it and then work out. It's easy for you. Now these 2 points, this is B dash, this becomes D dash. Finally, we join these points. Be careful, try to locate points, otherwise if you join some other corner, the answer will be wrong. A, B, C, D, E. Check this thing. Suppose that by chance if you keep like this is no man's land. This one is E for us. Be careful. Now, final front view, final top view. Let me check whether we have satisfied the condition. 30 mm sides, fine. It is inclined at 50 degree to HP lamina. Then the edge on HP is inclined at 30 degree to VP only. It is on HP, inclined only to VP. This is the final top view and front view. Okay. So this is how you solve a problem in the manually as well as computer. I will show you how to do it. Next, let me go for small change here and then try to work. Suppose that if we never gives this 50 degree, he will not give lamina inclination. He will give the top edge, so top corner in this case. See, this is the case. See here, instead of inclination, he will give BC is on HP, sorry, AE is on HP, say, for sequence I am considering this one, A, B, C, D, E, AE on HP. C becomes top corner. Suppose that it is corner condition, C is on HP, if these two are making equal inclination, AE becomes top edge. Now I have this problem, very easy to discuss. Top corner is some distance above HP. Instead of giving inclination, he will give this. How to deal with that? Same solution. I will show you how to do this job. I will in computer, I will show you this sequence. Now, this problem, after this, you take, I will use this. I will mark AE. Okay, second figure only I draw. AE. Forget about this problem. AE. Now, draw an arc. Draw a line. This is locus of C dash. This is the top corner position. Now, on this line only you should get C. What you do is, first figure front view, take and draw an arc. Then this gets you the, see this particular figure I am redrawing for this data. Suppose that this is 25 mm. above HP. The top corner is 25 mm above HP. So what you do is take 25 mm and front view length equal to radius, draw an arc. Then this gets you inclination theta. That's all. Next, rest of the things are same. You can go on working the same fashion. Okay, this is how you work a problem on pentagon. The criticality of the pentagon is keeping these figures manually. In case of computer, it is easy. Only thing is you have to set this in computer. How to set in the computer, I will tell you. Now, let me take one more problem. Hexagon problem. See, a hexagonal lamina of 30 mm sides as a side on HP. Again, same thing, edge condition with respect to HP or side on HP. Such that the first version I will take. First version is, let me take 25 mm and this is say 30 degree. Okay, some angle I will take. It can be 40 degree or 50 degree, whatever. Okay, now to work out this problem, let us understand the problem clearly. The lamina of 30 mm sides as a side on HP. Yes, side on HP. The top edge, this is the top edge, or sometimes they will give the side opposite to the edge on HP. Same thing, top edge. When it becomes top edge, in this case it's very clear. Degrees of freedom is 0 here. See, you cannot do only this one, but while rotating, you can rotate like this. Only this rotation I can do, give inclination to HP. Top edge is this. In case of corner, I can do anyway. Degrees are many, but here the edge is restricted. We can do only rotation. While doing rotation, I can say this is the problem with top edge. The top edge is 25 mm above HP, and see, in first version he says the side on HP is inclined at some degree to VP. See, this is what I do. Suppose that if I give to top edge only, it works same thing. If they give top edge inclination to VP or the edge side on HP to VP, same thing, because these two are parallel. So try to understand this. The version may be different in your question paper or test or class work. So I take this. The top edge is 25 mm above HP and inclined at 30 degree to VP. Same thing. Whatever I have given, it means same. So you must concentrate on from where you have to start. Whether to start from top view or front view. It is definitely top view because it says top edge is some distance above HP, means if I normalize situation, first position, second position. I cannot give inclination to VP any time because it says in that case the edge on VP, the farthest edge from the VP is so much distance. Here I have very clearly the top edge is 30 mm from above HP. So what I have to do is, this is the situation, final situation is this or this. Now let me normalize the situation. I have inclination totally to HP. Now I can make it parallel or keep it on HP. I get the top view as true share. So start from top view. Now I will draw the figure. Now in case of manual construction, it's very easy. I will show you here how to construct hexagon using radius method, arc method. You can do. Draw a circle of side equal to radius, like this. Then if you want corner here, draw two arcs, from this point two arcs. Very easy to get. All these should be construction lines, manual I am telling. Suppose one more set I have, draw circle. If you want this side corner, edge condition, these two as centers, draw two arcs with a radius equal to 30 because side equal to radius. Take this as center, draw arcs. Then you get the hexagon. So this is how you get, this is the way you get the construction manually. But in computer, you can directly get the hexagon or pentagon, whatever the polygons, by radius, particular radius, and change it to your requirement. Hexagon is very easy, by radius equal to the side. Now let me start working. I want the side. So what you have to do is, you must keep the side perpendicular to Okay, this one, A, B, C, D, E, F. Perpendicular to, okay, this one, like this you have to keep. Okay. Now, what I do is, I will try to mark using this. Same method you can use. Okay. Let me dark this. So this is A, B, C, D, E, F. Should not deviate from this norm. This is left extreme nearest corner, visible points A, B, C, D, E, F. This gets you very clear area sequence here. I will tell you how. Then dimension it carefully. It is given 30. Okay. Project it. So name these points. This is A dash, B dash. This is the advantage of giving, starting from this, invisible points, next invisible points. This is D dash, and also you will get clear idea, no confusion. Okay. Then dark this portion. This is first figure front view. A, B, C, D, E, F corners. This is the front view, and this is top view. Top view is true shape. Next, what you have to do? I have to do this job. If I do like this, the side opposite to the side on HP or top edge is 25 mm above HP. Yes, this is how you get. See, this is HP. This is the edge on HP. This is the top edge or the side opposite to the edge. You should maintain 25 mm. Instead of giving inclination, he has given the height. That's all. Already I explained that with the pentagon. So here it's a typical problem since long time. You are getting this. Now what I do is I will mark one point, then name this as A dash, F dash. It's very clear. You maintain some gap. Then draw a line. Draw a line in the height of 25. This is locus of C dash D dash. C dash D dash. On this line only you should get. If I get inclination, what I do is I draw a line and fix that using compass. In computer you move and rotate. Here it is fixing the end. I don't know the inclination. Simply take this equal to radius, draw, join them carefully. You get C dash D dash fixed. Then how to fix this? It's very easy. Particularly a characteristic feature of hexagon, square, etc. is this type of edge condition, corner condition, etc. You get exactly half. You will get into the sketch indication midpoint. You need not note down. Simply you mark P dash, E dash. Otherwise you can have a line also for your reference. No problem. But in manually you should do it. Take this arc and draw it. Even though it is midpoint, you can do it. Now you can find inclination with respect to HP. Theta is how much. You can find. Sometimes it will ask you how much is the inclination. Next, get the top view. Again, as I told you earlier, you keep two stoppers. One is at the right extreme and then lowermost. Should not go out of it. Even draw thin line. Then E will stop here. Again, B is already available here. This is E. Then if you draw two lines, that fetches 4 points for you. See, I have drawn two lines only, you get 4 points ready. This is C, this is D, this is F, this one is A. So you can optimize your method of working by drawing minimum number of lines and get the points. You should not go on searching points, it's easy. Now A to B, E to D, then C to B, E to F, then join this. That's all. This is final second figure top view when it is inclined to HP or its top edge is 25 mm above HP. Instead of inclination, I have given top edge. Next, we have to take this, the side on HP is inclined at 30 degree to VP, this one EAF. If you give this version, you must dimension to AF. Suppose that if other version is 25 above HP and inclined at 30 degree to VP, you should consider this. Both are same, inclination will be same, but you should dimension to CD, not to AF. At the same time, you should not take any other side. You must stick to AF for the first version. If you must stick to CD in second. Suppose by chance you give to AF only, there is no worry, but dimension it to CD in second for second version. So what I do is, assume that I am getting second. You know, you are familiar with AF, because AF you take nearer to it and then do it. But if I get CD as the reference, top it, how you do it? It's easy. You take CD little away from it, draw a line. Because I have to manage this space, this you draw, that is 30 degree. Then mark DC. Carefully take this distance and mark. Again, how to mark this? Manually. In computer it's easy, move and rotate. Manually it's again, draw perpendicular lines, two perpendicular lines, mark these 2 points. Take this and this one. Take one distance that works for 4 points. I have taken only one distance, and it's because of symmetry, easy. Then join this directly, you get one side, this is another side, then you have the midline, take this distance, mark. That's all. No worry. It's easy to redraw. Only thing is you should know how to redraw a geometrical figure easily. This is A, B, C, D, E, F. Prefer to, if you are working, you keep always vertical, then join them. Okay. Next, this is only for understanding. If you want, you can keep it sufficient. In computer, you can move away from that. Then draw this. Again, draw projection. AF is exactly on XY line. This is A dash, F dash. Then CD is the topmost points, CD, C dash, D dash. Then BE projected already, then project on that. This is B dash, this is E dash. So I have taken an approximate inclination. I think I have taken almost 45 degree, but if you take 30 degree, it may be little bit away other side, but the concept is same. Anyway, I will show you on computer how to do it. A, B, C, D, E, F. So this particular figure is referred as final top front view. This is final top view. You can easily realize what exactly I have done. See, the top edge CD is inclined at 30 degree to VP. Now, I have done this for drawing purpose, but finally you try to understand for what they have given inclination. Even this is correct, absolutely correct, but should dimension it to either, if they ask first version AF, you must dimension, project and do it. If they ask second version, you must dimension it to CD. Now let me dimension it to CD. This is 30 degree. So the CD is top edge. You can see the topmost edge that is parallel to HP and inclined to VP. Or side also same thing. It is on HP and inclined at 30 degree VP. This is how we can solve problem. Whether they give the inclination or the top edge, definitely you can. This is how they change the problem. That's all. Okay. So these are the ways of working the problems on pentagon and hexagon. So I will work the same on computer software. Let me take a problem on pentagonal lamina. A pentagonal lamina of 30 mm sides has an edge on HP inclined at 30 degree to VP. Draw the projections when the surface of the lamina is inclined at 50 degree to VP. Already we worked out the same problem on the whiteboard. There we have considered the same angle of inclination with respect to HP and the inclination to VP also same thing. Now I will discuss briefly the edge or side on HP. Then the lamina is inclined to HP. Definitely you must start with edge condition with respect to HP. That also you know, start from top because you will get the true shape on HP. This is how you get the edge to the left side always for the most of the lamina, unless the condensation remains a different position. Otherwise, the same condition by default you have to start. Then how to draw a pentagon? Now you have choice of you know, the polygon by center. So you will get these details. Here we have side 6. I want 5. So I will repeat this figure for your convenience. Now if you start and drag it, you will get pentagon. See, automatically you will get pentagon. If you want the edge condition, then you must do like this. If you want color condition, this way. See, the arrow and some line, the blue line is coming, it's horizontal, vertical. Then you must set. So fix this. Then go for smart dimensioning. Smart dimensioning, it gives you how much you want. Say this 30. Don't worry about this, gets you. See, then you move this to required position. Okay. Or if we can fix at a particular position, you move to this position and then see, I have edge condition. So this is how you can create the pentagon particularly. Okay. Now assume that I have already fixed this. Now this is the edge condition with respect to HP. Top is the true shape. Name this and then project this to the front view. You get A dash, E dash, B dash, D dash and C dash. These are ABC. Start from the left extreme nearest corner. Dark these two. Now once you take this, you have to give inclination to the HP by 50 degree. You must be very careful, 30 and 50. Okay, if you do ulta, it's a problem. Take care, inclination with respect to HP is 50. You take this front view length 50 degree to the XY line. That means you are giving inclination to the HP with respect to the lamina. So you know how to move and rotate. So this is how you get the points. But the thing is how to identify BD. Okay, in case of square and other things, it's easy. You project it, you get the corner. But here it is. Problem is here point is there. In case of hexagon also you get midpoint, some reference. But there also if it is corner condition you get 2 more points. How to do it? So while working this, while drawing this front view only, you take this is one entity, another entity. I have done like that only. See, you can see red mark here. Again you can see red mark here. This if I select, I will select only this. Then this end point will come so that you can project as BC. So for convenience, you can take line command and then draw a small line perpendicular to it, thin line and do it. That's what you can do. Otherwise, you can measure this and then draw a line. That can be done. Either way it works. But you should know how to locate these points. So I have located those points and then project it and get the points ready. Assume that I optimize this by using the alignment indicator. For example, if I want to project this, see, I will show you how to do it. This is line command. You see that this is thin line. Now see, alignment indicator, mark this. Okay. Now take B. Already I have marked 2 entities I have done. The end of this line you will come. Otherwise you go for different marking. Whichever is easiest for you, you do it. See, this is for BD. You take D as reference, B as reference and draw this line. Again, this itself gives you D on the same line. Next extreme A is here, lower, and touch with this A. Draw. Then C. Unnecessary projections you avoid. You do only this. Okay. Now, assume that I have done that job and then name these points as A, B, C, D and join this and gets you the final top view. Next, AE is the reference for us. See, he says the edge on HP is inclined at 30 degree to VP. So that is very important. Now, this AE must be inclined at 30 degree to VP. Right now it is perpendicular. So what you do is you move this and rotate so that AE is inclined at 30 degree. I will do that for your convenience. Now take move command and see that this is shadow here, yes, dot, then complete thing, you move about C, then do this way, then rotate this. How to rotate? You need not fix 30, you directly take it. Now rotate command, take this E as a reference, center point, then rotate. If you want to do 30 degree to XY line with vertical, you must give 90 minus of that, 60. Yes. Then dimension it. Before, don't proceed until you get confirmed this angle. Sometimes it may vary because of different reasons, technical reasons, or any error you do. See, 30 degree. So this is how you do it. Once you do that, you project it and get the final top view. So this is what I have done for you. See, this one, I have done that job for you. Then project it. Here also I have used alignment indicator. None of the points are having extra lines, unnecessary lines. You know very well that A is on XY line and BD midway, and then C is the topmost corner. Yes, alignment indicator use and then do it. Now project it and get the points. Now AE is the side on HP, inclined at 30 degree to VP. That is nearer to the XY line. Suppose that in question paper or question in classroom or test or exam, you get AE, that is the side on HP or edge on HP is nearer to the observer. Then what you do is take this and then take away from it. That's all. I will show you how to do it. Now I have taken this. Okay. Now you take AE away from it. Now the thing is here. See, instead of A nearer, you can take away. So identified this with different color. Then you can project. The answer is same. Only the side on HP is nearer to the observer if they give. Then only you do this. Otherwise, even if you do it, no problem. That is correct. But by default, you take the previous one. Okay. This is also absolutely correct. Okay. Next. As I explained earlier, suppose that they give, instead of giving inclination to the HP with the top, lamina, they give top corner 35 mm to HP. So already I explained that locus of top corner C you identified 25 mm above it. How to identify? Then I will show you how to do it. I will remove this. Now you draw a line at random. Draw a line at random. But it must be parallel to the XY line. Yeah. Then see that this is 25 mm above HP. Take distance between this line and this line. Okay. You will get something 36.78. But I want 25 mm. So I keep 25 mm. That's all. So this becomes locus of C. So this is how you work. Like this here 35 mm is there. Yeah, I thought that 35 mm. You can keep any value. Okay. Now this 36 is there. Now I want 35. Yes. Now how to proceed? Yes. Take this 35 mm all across. Take front view length equal to it is draw an arc. Okay. Then you get the point. You identify this BC. BC you measure this and mark. Otherwise you make different entity here. I have done that job actually. This is different. See, this is different color. Then this is, if I select this becomes different. Now you keep this distance, or you can have the initial stage and then do it. Now you name it next BC, and this one is C is missing here. Yes. Then finally you try to get, this is C dash. It is very important. Keep C dash carefully. C dash. Okay. Now let me take two. C dash. So this is how you get the front view and corresponding top view. See, this is what, after doing this same procedure, no change in the previous problem. Only thing is, instead of angle, see, I got the angle 49 degrees. Especially in the manual working, I took this as 25. Now I am taking as 35. Then they will get alternately. There I got some, I will get some value lesser than that. Next, corresponding final views. You know, AE must be inclined at some degree to VP is given this way. So 30 degree to VP. Now I have taken that and then finally completed. So this is how you complete the problem on pentagon when angle of inclination is given to the lamina or the top corner. Yes, that you can do. Same procedure. Now let me take up hexagon problem which I already worked out in the board. The external lamina of 30 mm side has an edge on HP. You don't get confused with edge on side. Both are same. And inclined at 30 degree to VP. The projections, draw the projections, the top edge is 25 mm above HP. As I already told you, the edge on HP is inclined 30 degree to VP, or they can give, if they miss this and then add here only. The top edge is 25 mm HP and inclined at 30 degree to VP. See, this particular item will be, here I am going to keep AF on HP. Definitely the top edge will be CD. Same procedure you have to follow. Take 25 mm and then front view length equal to radius, draw an arc, this gets you CD. Then draw the final projection of in second figure, keeping this midpoint. You need not mark anything. Still, for identity, you must take some line or something. If you click on this, you will get midpoint using utility sketch or this one line you have marked, whatever. But for naming, better you take one line. It will work out in the next session. Okay.